and I will explain the answer for question number 1. Probability sampling is a sample that the subject of the population get an equal opportunity to be selected in a sample. It also known, probability sampling also known as random sampling. It is randomly selected. It have the same probability or fixed opportunity. It used for conclusive research. It also produce unbiased result. Probability sampling used for objective method. Use objective method to find probability sampling. That is what it means. The next one is it can make a statistical inference and the hypothesis is tested. Next, non-probability sampling. Non-probability sampling is also known as non-random sampling. Non-random sampling means that there is no specific subject in the population will be selected as a sample. It is arbitrarily selected. Non-probability sampling, we don't have the probability is unknown or non-specified. It used for exploratory research. It's also produce biased result. To get non-probability sampling, we use a subjective method. Also can make an analytical inference. The hypothesis is generated. For the second part, the advantages and the disadvantages of probability sampling and non-probability sampling. Okay, probability sampling is the advantage of probability sampling. The first one is it have a less risk of carrying an error. The second one, it is equal chance of selection because, as I mentioned before, it have the same probability or fixed opportunity. Third one is the simplest data collection, and the last one is it is easier to form sample group because, as I mentioned just now, it is randomly selected, so it is easy for us to form a sample group. The next one is the disadvantages for probability sampling. Okay. The first one is it is a complex and time-consuming method of research. That means we have to take a long time to do this probability sampling. Okay. The next one is there is an added monetary cost to the process, which is it is a bit costly. For the third one is there is no guarantee that the result will be universal in offer. And the last one is large sample size is mandatory. Next is non-probability sampling. The first one is the advantages for non-probability sampling. The advantages for non-probability sampling is firstly the possibility to reflect the description about the sample. The second one is cost effectiveness and time effectiveness compared to probability sampling, which means it not take a long time and it not take a lot of money to do this non-probability sampling. And the last one is effective when it is unfeasible or impractical. For the disadvantages of non-probability sampling is firstly it lack of representation of the entire population. The second one is it have a lower level of generalization of research finding compared to probability sampling. And the last one is difficulties in estimating sampling, variability, and identifying possible bias. In general, is non-probability sampling is the first one. For the advantage is there is more accurate because you are targeting a specific group, therefore your answer will be similar to what the rest of the population will answer. For the disadvantages for non-probability sampling is this is more biased because the individual chosen are not at random, so they also might not represent what another population think, so it is biased. The disadvantage is it is biased.
Hi, so we will move to the next part, which is simple random sampling (SRS). So SRS is the basic sampling technique where we select a group of subjects or a sample for study from a larger group of a population, and each individual is chosen entirely by chance, and each member of the population has an equal chance of being included in the sample. So there is no bias here. There are two methods that we can use to select a sample. So the ways are SRS with replacement and SRS without replacement. So the difference between with replacement and without replacement is the SRS with replacement. Each unit has an equal chance of being selected, but for without replacement, any one of the remaining units have the same chance of being selected. Next is the procedure of selections. So there are 6 procedures, which is the first step is define the populations. So we need to identify the capital N units in the population from 1 to capital N, which also known as the sampling frame. For the step 2, we need to choose the sample size. So here the sample size is expressed as small capital N. So the number of selected sample are based on the limit of budgets and also the time needed to distribute the questionnaires. For the step 3, we need to list out the populations. So here we need to identify the sampling frame in order to get the valid sample. Okay, for the step 4, assign numbers to the units. So here for each unit of sample, you need to put consecutive number from 1 up to N, capital N. So the next step is step 5 is find a random number. So here you can use either the random number tables or the computer programs such as Excel that will generate the number for you. For step 6, select the sample. Advantages and disadvantages of SRS. So the advantages are, first, the unbiased representative sample. So each of the individual in the population have an equal opportunity to be chosen as a sample. The second one is simplicity. So SRS is much less complicated than the other sampling methods such as stratified sampling. So the disadvantages is, first one is high consumption of time. This is because the organization that keep the individual data often impose lengthy retrieval processes. So the second is the difficulty assessing list of the population list. So here, some of the organizations are not willingly to provide the complete list of the individuals that we need for a research. The third one is cost. So it may require payment for each time data is provided from the third-party provider. And the fourth one is sample selection bias. The sample selection bias can occur when the sample of the larger population is not inclusive enough and representation of the full population will skewed, and it will require additional sampling techniques. So here, if to ensure the bias does not occur, researchers must acquire responses from an adequate number of respondents, which may not be possible due to time or budget constraint. So next is estimation of parameters in a simple random sampling. So in SRS, we will estimate the mean, population total, variance, and also proportion for the populations. So the estimation of population mean is X bar. So the next is population total. So the term we use for population total or the estimator is the top hat. So the next is variance of sample mean. So here the estimator for the variance sample mean is the sigma hat x bar square. So next is the percentage of confidence interval. So the percentage is 1 minus alpha. Next, the estimator of proportion is p hat. You can find p hat same as you find the mean, which is x bar. For the variance of proportions, you need to, the estimator you use is sigma p hat power of 2. You can see the formula in the slide. Next is the estimating sample size. So we have three estimation, which are the first is estimating the mean, the second one is estimating the total, and the third one is we estimate the proportions of populations.
Today I'm going to present about the stratified sampling. In stratified sampling, the total elements is divided into small groups based on some common characteristic in the population data. It is known as strata. The random sample is taken from each stratum in direct proportion to the size of stratum compared to the population. This is to ensure that the observations from all relevant strata are included in the sample. The picture shown in the slide is let us know how to select the sample from the population. Next, the step in the stratified sampling is first to define the population, then choose the relevant stratification, and then we list out the population and list the population according to the chosen stratification. Next, we can choose the sample size. Next, we calculate the proportionate stratification, and lastly, using the SRS to select the sample size. Next, I would like to talk about the difference between stratified and cluster sampling. For the stratified sampling, the strata are constructed within homogeneous, whereas for the cluster sampling, the cluster is constructed within the heterogeneous. Other than that, in stratified sampling, the strata is constructed among heterogeneous, whereas the cluster constructed among homogeneous. The advantage of stratified sampling firstly is data of known precision may be required for certain parts of the population. Other than that, the sampling problem differ in different parts of population. Next, it is more convenient to stratify a sample than to select a random sample in stratified sampling. Stratified sample guarantees better coverage of population. Lastly, the population mean of population total can be estimated with a higher precision in stratified sampling. The advantage of stratified sampling firstly is data of known precision may be required for certain parts of the population. Other than that, the sampling problem differ in different parts of population. Next, it is more convenient to stratify a sample than to select a random sample in stratified sampling. Stratified sample guarantees better coverage of population. Lastly, the population mean of population total can be estimated with a higher precision in stratified sampling. Next, I would like to talk about the estimation of parameter. The equation in the first column is to estimate the population mean and variance. The equation in the second column is to estimate the population proportion and variance. For the third column, the equation is to estimate the population total. Next, to determine the sample size, the first equation in the slide is to find the proportional allocation. The second equation is to estimate population mean and total by using optimal allocation. The third equation is to estimate population proportion by using optimal allocation. Next, for the non-proportional allocation, the first equation is to estimate the population mean by using non-proportional allocation. The second equation is to estimate the population total.
Systematic sampling. Systematic sampling is a type of probability sampling method in which choosing the element from a target population Selecting a random starting point as a sample and after that fix the sampling interval. This sampling method is likely to an arithmetic choice of object. Systematic sampling have a lot of advantages. The first advantage is convenient and systematic. Systematic sampling is operationally more convenient and systematic than simple random sampling. The second one is the technique can be implemented for both small and big population size. Example, the small population size like the student of SQQS, while for big population size like people live in Kedah. And the last advantage is increased accuracy of sampling error estimation. Every sample has the same probability to choose, so it can increase the accuracy of sampling and avoid mistake. So, the disadvantage of the systematic sampling is may give the biased result and may interact with some hidden pattern in the population. If a pattern in the population exists and it coincides with the interval set by the research, randomness of the sampling technique will be compromised. The next disadvantage is large variance. The systematic sampling will give us large variance when we connect. Next is periodicity. Example, New Year season and so on. The last disadvantage is greater risk of data manipulation. The researchers may be able to construct their system to increase the likelihood of achieving a target outcome rather than letting the random data produce a representative answer. So, any resulting statistic cannot be trusted. Procedure of systematic sampling. To conduct this method, we need to follow the steps. So, step 1, we need to prepare the population in a list. And then step 2, randomly choosing the initial object from the beginning of the list. And after that, step 3, select every K object. And the last step is stop choose the sample when the needed sample is obtained. This picture is showing the systematic sampling method. From the picture, we can clearly see that we choose 9 samples from the population. To know the K, we use the formula K equal to population size divided by sampling size. So K equal to 3. And we start the initial starting point at the third item. In this case, every third is systematically selected, and which is 3, 6, 9, and so on. Let's move on to the estimation of parameter. The first column is the formula estimated of the population mean and variance. To calculate estimated of the population total and variance, we use second column formula. The last column is the formula estimated of the population proportion and variance of population proportion. To selecting sample size, we use these two formulas. The first one is sample size to estimate mu. N equal to m times variance divided by n minus 1 times d plus variance, where d equal to b squared over 4. The second one is sample size to estimate proportion. N equal to n times p proportion and times q proportion divided by n minus 1 times d plus p proportion and q proportion, where d equal to b squared over 4.
Cluster sampling is a probability sampling technique where researchers divide the population into multiple groups, which is clusters, for research. Researchers then select random groups with a simple random or systematic random sampling technique for data collection and data analysis. Cluster sampling is a sampling plan used when mutually homogeneous yet internally heterogeneous groupings are evident in a statistical population. It is often used in marketing research. Next is steps in doing cluster sampling. First, sample. decide the target audience and also the sample size. Second, create and evaluate sampling frames. Create a sampling frame by using either an existing framework or creating a new one for the target audience. Evaluate frameworks based on coverage and clustering and make adjustments accordingly. These groups will be varied considering the population, which can be exclusive and comprehensive. Members of a sample are selected individually. Third, determine groups. Determine the number of groups by including the same average members in each group. Make sure each of these groups are distinct from one another. Next, select clusters. Choose clusters by applying a random sampling. Finally, create subtypes. It is bifurcated into two-stage and multi-stage subtypes based on the number of steps followed by the researchers to form clusters. Next, we go to advantages and disadvantages of using cluster sampling. There are 4 advantages. First, consumes less time and cost. Sampling of geographically divided groups requires less work, time, and cost. It's a highly economical method to observe clusters instead of randomly doing it throughout a particular region by allocating a limited number of resources to those selected clusters. Second, convenient access. Researchers can also choose large samples with this sampling technique, and that will increase accessibility to various clusters. Next is data accuracy. Since there can be large samples in each cluster, loss of accuracy in information per individual can be compensated. Next, ease of implementation. Cluster sampling facilities information from various areas and groups. Researchers can quickly implement it in practical situations compared to other probability sampling methods. Next, we go to disadvantages of using cluster sampling. There are 2 disadvantages. First of all, higher sampling error. The ratio between the variance of an estimator made from the samples of the cluster study and the variance of an estimator obtained from a cluster of subjects in an equally reliable, randomly sampled unclustered study. The more there is heterogeneity between clusters and more homogeneity between subjects within a cluster, the less accurate our estimators become. Next is complexity. Cluster sampling is more sophisticated and requires more attention with how to plan and how to analyze. For example, how to take into account the weights of subjects during the estimation of parameters and confidence intervals. In the above slide, you can see there is a cluster random sampling picture. That is how the cluster random sampling is held. Next slide is about estimation of parameters for cluster sampling. For population mean and variance, we have the formula there, and also for the population total and variance. Next is population proportion and variance. Next slide is on selecting sample size for cluster sampling. Approximate sample size required to estimate mu with a bound b on the error of estimation. The formula is n equals n times sigma square r over nd plus sigma square r. Next, approximate sample size required to estimate total using my with a bound on the error of estimation. N equals the same formula, and where sigma square r is estimated by d equals p square over 4n square and sr square or st square equals summation of yi minus yht squared over n minus 1. Next slide is on selecting sample size for estimating proportions.
Two-stage cluster sampling. A two-stage cluster sampling is obtained by first selecting a probability sample of clusters and then selecting a probability sample of elements from each cluster. Two-stage cluster sampling is an extension of the concept of cluster sampling. Moreover, the efficiency in cluster sampling depends on the size of the cluster. As the size increases, the efficiency decreases. It suggests that higher precision can be attained by distributing a given number of elements over a large number of clusters, and then by taking a small number of clusters and enumerating all elements within them. In subsampling, the first thing that we have to do is divide the population into clusters. Second, select a sample of clusters, this is the first stage. Third, from each of the selected cluster, select a sample of the specified number of elements, this is second stage. The clusters which form the units of sampling at the first stage are called the first stage units, and the units or group of units within clusters which form the units of clusters are called the second stage units or subunits. This is an example. A pictorial scheme of two-stage sampling scheme is as follows. First, population MN units. Second, population and clusters, large in number. Third, first stage sample and clusters is small in number. Fourth, second stage sample M units and cluster, large number of elements from each cluster. Note, the expectations under two-stage sampling scheme depend on the stage. For example, the expectation at second stage unit will be dependent on the first stage unit in the sense that second stage unit will be in the sample provided it was selected in the first stage. When it is used when the size of the clusters are large, making it difficult or expensive to observe all the units inside them. For example, the situation when the one wishes to estimate total landing per trip of a fishery with many landing sites and also with a large number of vessels. Sometimes, in order to decrease the size of the primary sampling units, one can previously stratify the population and apply two-stage sampling to each stratum. It is possible to extend the two-stage sampling design to 3 or more stages. A short reference will be made to a 3-stage sampling design, using a case where the procedure to estimate errors is simple. The notations: unbiased estimator of the population mean, estimator of the population mean, assume as SRS at each stage. Then the estimate variance of mu hat, estimation of the population total, estimate variance of T hat, ratio estimator of the population mean, estimate variance of mu hat, the estimate of mu with bound on the error of estimation, estimation of the population total, estimate variance of T hat, the estimate of population total with bound on the error of estimation, estimation of a population proportion, estimation variance of P hat. The last one is the best estimate of the proportion. Advantage: first, more flexible than the one-stage sampling. It reduces the one-stage sampling when M equal to M, but unless this is the best choice of M, we have the opportunity of taking some smaller value that appears more efficient. As usual, this choice reduces to a balance between statistical precision and cost. When units of the first stage agree very closely, then consideration of precision suggests a small value of M. Second, sometimes it's cheap to measure the whole of a unit as to a sample. For example, when the unit is a household and a single respondent can give as accurate data as all the members of the household. Disadvantage. First, bias samples. The method is prone to bias. If the clusters that represent the entire population were formed under a biased opinion, the inferences about the entire population would be biased as well. Second, high sampling error. Generally, the samples drawn using the cluster method are prone to higher sampling error than the samples formed using other sampling methods.
Okay, last but not least from us is the reasons why the sampling methods are being used in most studies. So most researchers aim to gather the data from a sample rather than from the entire population because they are aware that the resources are limited, like time, money, and also people. So here we go with 5 reasons, which are the first one is save time. So here, by contacting everyone in the population will take more time because some people will not respond to the first effort at contacting them. That makes researchers have to invest more time for follow-up with them. So random sampling is much faster than surveying everyone in a population, and obtaining a non-random sample is almost always faster than random sampling. Thus, sampling will save researchers lots of times. For the second reason is save money. So sampling save money by allowing the researchers to gather the same answers from a sample that they would receive from the population. The non-random sampling is significantly cheaper than the random sampling because it lowers the cost associated with finding people and collecting data from them. Because all research is conducted on a budget, so saving money is very important. So the third reason is collect a richer data. So the sampling will allow researchers to ask participants more questions and to gather richer data than thus contacting everyone in a population. So next is generalizations. So we can make generalization from a sample for the whole populations. And also the generalization of results from a sample means that we also accept a certain amount of error. So this can also be explained and in the picture that we include in this slide. So that's all from us. Thank you very much for your time.